Everybody, and once again welcome to Pankaj Sir's Echelon Tutorials. In this today's session, I'm going to start with a very interesting topic in mathematics that is known as transformation of graphs, right? Now you know that these functions, there are various types of functions, and different functions can be represented by different graphs, right? And these graphs, they can be transformed, they can be moved, okay, or they can be changed from one form to another form. And that is exactly what we are going to study in this particular session. Okay, maybe this will take a couple of sessions or maybe more, because I'm going to teach you this transformation of graphs very much in detail, right? So let us get started. Now, I have already explained you what is transformation of graphs. Okay. So, starting with basically, there are four types of transformation that you have to take care of. Okay. Or that you should know. Okay. Now, number one is there is something called a parent graph of y is equal to f of x must be given to you. Okay, and it can be any graph. It can be a sine x graph, it can be a cos x graph, it can be a x square graph, it can be a root x graph, it can be log x graph, it can be absolute value graph. Okay, so whatever may be the function, the graph of that particular function is known as a parent graph. Now this parent graph can be transformed in four different ways. Okay, so this is the parent graph number one, which will be given to you, y is equal to f of x. Now the possible transformations that are that you can study is T1 stands for transformation 1. This will be y is equal to f of x plus some constant k, where k is a positive value greater than 0. Okay, this is one kind of transformation, right? Second kind of transformation is y is equal to f x minus a k, where again k is a positive integer. Okay, so these are the two types of transformation that you can start with. And then there's a third one, which is y is equal to k times f of x. Okay, so again here k is a value which is greater than 0, it is positive. Then the fourth kind of transformation is y is equal to f of k times x. Okay, right? And there are two more transformation. Transformation 5 is reflection, that is something called reflection. So it is y is equal to minus f of x. Okay, and the sixth transformation is y is equal to f of minus x. Now these are the six possible transformations that you will have to study independently first, and then you should be becoming so much expert in this particular transformation topic that you should be able to apply a combination of transformation on a parent function like y is equal to f of x. Okay, so there can be a combination, there can be combined transformation that you'll have to face. Okay, maybe out of this six you'll have to face three or four or maybe five or all the six at a time. Okay, so this particular transformation of graphs topic is not that easy, so you'll have to go very slow and first try to understand things piecewise. Okay, that is, try to understand independent concepts, and then we will be combining those concepts together. All right, so as I told you, these are the six transformations that you have to study independently first. Okay, once again I am telling you, y is equal to f of x is known as a parent function or a parent graph, you can say. Okay, it's a parent function, and this parent function can undergo one of these six transformation or many of the transformations altogether. Okay, so parent transformation, parent function again can be of various types. Now I am not going to go in detail of all the parent functions, okay, because there are numerable number of parent functions, but I'll be considering some very important ones, and these are the ones I'm going to consider. So can you see y is equal to f of x, and these examples that I'm going to consider is y is equal to x square, number one, y is equal to root x, number two, y is equal to modulus of x, number three, and y is equal to sin x. These are the four peculiar types of parent functions that I'm going to deal with. And with respect to these four functions, okay, these four parent functions, I am going to explain you the various transformations, right? Okay. So our topic starts from here. Y is equal to x square has to be transformed to something which will be y is equal to x plus 2 the whole square. Now this x plus 2 the whole square, this first one is an example of this particular function, x plus k, function of x plus k. Okay, so can you say that if you compare this y is equal to x plus 2 the whole square with y is equal to x plus k, you will come to know that your k is 2 in this case. Okay, so what happens to a function, to a parent function, when some constant value, some constant number, positive number like k is added to x in a function? Now, when you add this constant value k, a positive constant value k, okay, to x, we say that you are performing the transformation in the domain of the function, or you can say you are performing transformation inside the function. Okay, so this is the language. Inside the function means you will do that addition, subtraction, multiplication inside the bracket of y is equal to f of x. Okay, so inside the bracket you have x, and this x is nothing but the domain. So it is also known as you are going to perform this transformation to the domain. Okay, so I can tell you that x plus k, x minus k, and k times x, and this minus of x, these 1, 2, 3, and 4, that is T1, T2, T4, and T6. All these four are transformations taking place in the domain. So I'm going to write here D for that. Okay. Or you can say inside the function. That is, with x, you are going to do plus k minus k multiplied by x, multiplying by k, or putting a minus sign to x. Okay, so all these are transformation that you are applying to the domain. Well, now, okay, I just skipped two more. Okay, so there will be T7 and T8. Two more transformations will be y is equal to f of x plus a k, and y is equal to f of x minus a k, right? Again, k greater than 0. It has to be positive, right? Okay. So total you have 8 transformation now. Okay. So this transformation number 1, 2, 4, and 6 are pertaining to the domain. So the changes will be happening in the domain. And now this T3, okay, and I'll mark with a different ink. So T3, and then this T5, and this T7 and T8. Okay, these are the transformations which are happening from outside the function. Okay, so can you see that k is being multiplied with f of x outside? Okay, then in this minus sign is put to f of x from outside. Okay, again here y is equal to f of x plus k. Here k is being added to f of x from outside. Okay, and here also k is being subtracted from f of x. Okay, so here all the transformations are taking place with respect to f of x, that is y. F of x is nothing but y, and y is, as you know, it is known as the range. So these are the transformations which are going to affect the range. Okay, or which are pertaining to range, right? Or you can say the y-axis. Okay, domain will be x-axis and range will be y-axis. Okay, so I'm writing this x-axis for domain and y-axis for the range. Okay, I hope you must be getting it. Okay, y for the range. Okay, fine. Now let us come to peculiar functions, like say y is equal to x square. Okay, so this y is equal to x square is a parent function, and if you do y is equal to x plus 2 the whole square, this indicates that you are going to add 2 to the domain. Okay, and now your function is going to be transformed. It will be changing. Okay, it will be transforming. So how to recognize, or how to see what is happening in the transformation, that you are going to understand now. Now, here is the graph which is showing, you can see here, 1 second. Yeah. Now, this is the graph of function y is equal to x square, which is a parent graph. And this is the graph of y is equal to x plus 2 the whole square. This is the transformation graph. Now, this particular transformation is T1. Okay, that is x plus 2. Can you see this? F of x plus 2. So, the transformation is happening inside the bracket, or it is happening in the domain. So domain is always shown by the x-axis, or domain is always represented on the x-axis. So whatever changes are taking place will be affecting or will be effective on the x-axis. So can you see this y is equal to x square ka graph? It is touching the x-axis at the point 0, 0. Okay, and for y is equal to x plus 2 the whole square, this same point has shifted from 0, 0 to minus 2. Okay, so the thing is, whenever you add some positive value to x, the graph will be shifted, the parent graph. Okay, the parent function graph will be shifted to the left. Okay, so I'll write here shifting to the left. What transformation takes place? Shifting to the left. Okay, now this shifting to the left takes place when you add some constant k to the domain x. Okay, now this I have shown you with respect to the parent function y is equal to x square. Now one more thing you can see here. Okay, don't just see that there is a shifting taking place. You can always take any 1 or 2 points on the graph and see what is happening to that point as well. Okay, so suppose in this y is equal to x square, that is the parent function, you are taking this particular point. Okay, which one? uh, this, the vertex. Okay, now the coordinate of this vertex will be 0, 0, right? Now here the coordinate of the vertex is changing to this particular point. Okay, so the coordinate in the parent function was 0, 0, and from 0, 0 it is changing to, it has transformed, after transformation the coordinate of this point is becoming minus 2, 0. Okay, can you see here the coordinate of this particular point, the vertex of this y is equal to x plus 2 the whole square, has become minus 2 comma 0. Okay, this was 0, 0. I'll write here for you. This is 0, 0 from the parent function, and this is minus 2 comma 0 in the transformed function. Okay, so whenever you add some constant to x, okay, the you can take it this way, that a point on the parent function, what will be the changes in the point? The x coordinate, you will have to subtract that particular value which you have added over here. So when you add x plus 2, here you have to do subtraction. So from 0 you have to subtract 2, which will give you minus 2, and your y coordinate is going to remain same. Okay, so these are the things that you should remember when you are learning transformation. Okay, number one, what is happening to the graph in terms of its position and what is happening to one or two points on the graph of the parent function and the transform function. So that also you should try to understand. So with respect to the first function, y is equal to x square as a parent function, this is what I wanted to tell you. So transformation here is T1, okay? And coming to the next one, now here I have changed the parent function from y is equal to x square to y is equal to root x. Now the parent function is y is equal to root x, and this is the graph of y is equal to root x, right? Now, when you want to transform this function by the same transformation T1, okay, so what was T1? As I told you, T1 is nothing but adding some positive value to x. So let us add 1 to x in this function. So it will become square root of x plus 1. Now when you plot the graph of square root of x plus 1, this is the kind of the graph you will get. Now try to compare the two graphs. What can you see? Now I can see that in the transform graph, okay, the graph has been shifted to the left, okay. So again, the same thing is applicable here also, as what I have written here, shifting to left, okay. So here also shifting to left. The graph is shifting to the left, okay. When when we add some positive number k to x. Now that is what you can see. Again here, let us check the coordinates. So let us take this particular coordinate. This is 0, comma 0 in the uh, parent graph. And here in the transform graph, it is minus 1, comma 0. Okay. Now see, any point is written in a horizontal way like this 0, comma 0, minus 1, comma 0. And this is, I have written in the column vector form. Okay. 0, comma 0, or this can also be written this way. Okay. This is column vector form. Column vector form is nothing but a point which is represented in a vertical form. Okay. In a point representation, you have x and y coordinates, and you have a horizontal way of representing. Here you have x and y coordinate, but they are in the vertical way. Okay. So x is on the top and y is at the bottom. Okay. So all you can do is you can always convert a point into a vector form also. So here 0, comma 0 is this particular point on the parent function, and minus 1, comma 0 is the point on the transform function. Now, what transformation has resulted, the x coordinate, we have subtracted 1 from the x coordinate. So from 0, if you subtract 1, you'll get minus 1. At the same time, keeping the y coordinate same. So I hope this is also understood. See, here also the same thing had happened. To 0, from 0 you subtracted 2 and you got minus 2 over here, and y coordinate you kept as it is. This is known as keeping y invariant. Y is invariant. Y is not changing. Here also y coordinates are not changing. It is remaining same. So it is invariant. And this 0, I mean the x coordinate, you have to subtract. Okay. In the function when you add, okay, in the transformation function when you add something to x in this point, in the coordinate, you'll have to subtract. Is that clear? Next is the modulus function. Modulus of x is shown in this way. This is the graph, and we are going to see this particular point. Okay, this point is 0, comma 0, and in this transform graph, that is y is equal to modulus of x plus 2. Okay, the graph has been shifted to the left again to this particular point, and the coordinate of these points are minus 2, comma 0, isn't it? So again, you can see that the point 0, 0 in the parent function has been transformed to minus 2, comma 0 in the transform function. Now, why minus 2? Because 0 minus 2 will give you minus 2, and y coordinate you have to keep it as it is. So it is 0, so this will also be 0. Okay. So again, this is shifting of graph to left. Okay, so whenever you do f of x plus k, where k is a positive integer, the graph will be shifting to the left by that much amount of k. Okay, so shifting of graph to the left is seen when you add some value k to x. Okay, fine. One more example we are going to take. Let us take example of cos x. So cos x ka graph is this one, and cos of x plus 2 ka graph is this one. And if you see carefully, now let us take an point of 0 comma 1. So this is that point. Okay, this one. This point is 0 comma 1. Now this point has shifted to the left because of this transformation x plus 2. So when you add something to x, the graph will shift to the left. Now can you see this particular point 0, 1 has shifted now to this particular point. And this point coordinates are minus 2 comma 0, minus 2 comma 1. Okay. So here again you can see that 0, 1 is the point on the parent function, and minus 2 comma 1 is a point shifted to left, okay, in the transform function. Now how much it has shifted? It has to shift by 2 units on the left hand side. So you can see 0 minus 2 will be minus 2, and your y has to remain invariant. Y will remain unchanged, right? So that was today's task of just understanding the start of this transformation. I have made you understand the basics, very basic. I have just one transformation I've tried to make you understand, that is f of x plus k. Now in the next session, in the next video, I'll be explaining you the transformation f of x minus a k. Okay, so for today's session, that's all, and I'll wind up this session for today, and in the next video we'll be starting with the next transformation, that is f of x minus k. Thank you very much for being with me. Goodbye, take care all of you.